So this video is about 2.1, which is the nuclear atom, and I'll cover both 2.1 about the nuclear atom as well as the mass spec. So in this case, this one it's page 9 and 10, all of it in your study guide. So let's look at that. Page 9 and 10. It's page 5. By the way, in your study guide, there are a number of questions here, which is not a bad idea to practice. However, at this point, you might not have learned quite a bit yet. So, the nuclear atom, what atom is made of. Again, that's a review. We talked about this in class before about atoms, proton, neutron, electrons, the size of it, the structure of it. Now, the mass number. So, make sure you know this part. So the mass number will be on top, the atomic number will be on the bottom. So you can see some examples here. Beryllium, its atomic number is 4, but the mass number is 9. So in this case, proton number and the electron number is also 4, and you get this 5 from 9 minus 5, okay? Now, we talked about the isotopes in class before, basically things that have the same number of protons but different number of neutrons. Here are some famous examples of these isotopes. You don't need to memorize them, by the way. It's just knowing that you can tell the difference. Now, relative atomic mass. That's another topic you have learned back in grade 10. So in this case, let's look at this. You have a ratio between these two, which happens in a 3-to-1. Naturally, that means 75% and 25%. So in this case, now when we're talking about this, because if you look at a periodic table, you get like a decimal number, right? We said this in class before. It's a decimal number. The reason why you have a decimal number, even though you have whole number of mass number, is because it is a weighted average. So you have 35 the atomic mass of one type of isotope times the 75% of the other one. Okay, so use that as a times the 75% plus the atomic mass of chlorine 37 times it's only 25% of that of the chlorine atom is chlorine 37, so it's 25%. So in this case, you have a weighted average of 35.5. Okay. So, let's see. So page mass spec. We've been talking about this in the last few lessons. Remember, we mostly talk about the mass. However, mass and charge are would be affected too. So the amount of deflection depending on the mass and charge. You should have a brief idea of how it works. Okay, so there's vaporization, ionization, okay, acceleration, and then you have deflection and detection. Okay, so you have deflection and then detected after it hits. So smaller the mass, higher the charge, they're deflected the most. Larger the mass, smaller the charge, will be deflected the least. Oh yeah, the detecting part is here. So here's an example. Remember I talked about it in class where you can have two kinds of readout. One type is a relative abundance here. So it doesn't really talk about percentages. It just say of that particular sample, here's like the ratio between them. Okay. Now, so this is relative abundance. So you just read this here. That's a mass. So atomic isotope mass you have for lead, and this one you have 4 different peaks. So 4 different mass: 204, 220, 206, 207, and 208. And that's relative abundance. It will be a good idea to bring a ruler. Keep in mind that we will have a tolerance in terms of how you read it if such a question exists on the test. Now, in terms of calculating relative abundance, so what you do for this one here, it is 0.2, you want to find out of all of these isotopes, how much is 204. So to get this 2 here, so what you do is 0.2 divided by, let me go back. Okay, bracket 0.02 plus 2.4 plus 2.2, 2.2, and 5.2. And then you make that into percentage afterwards. So 0.02, you times 100, you'll get 2%. So basically that's how you calculate the relative abundance. And afterwards, you do again the weighted average to find the relative atomic mass for lead. Okay. Here are some use of radioisotopes. Keep that in mind what they are. That's about it. Now let's look at the practice test. And this practice test actually have quite a bit of 2.1. Not surprising because 2.1 it is essential material before you move on. So this one, 2A, 2B, question 3, you can see that relative atomic mass, you have to find it. Question 4, finding the relative abundance. And the last question, question number 9. Explain how to use mass spec to calculate REM, relative atomic mass of an element. So this question is really about the steps, okay? So let's pause here. Let's play pause and then try to do these questions, and then I will go over the answer with you, okay? So press pause right now, okay? Don't cheat. So at this point, I assume that you have done the. At this point, I assume that you have gone over the questions already. So let's look over these ones, okay? So, right. 2A, atomic mass number. Now, the wordings are not, these are pretty simple wordings. How do you calculate the protons, electrons? Now, this one is a tricky one simply because, as you notice, this is a charge. This is a positive ion. What does a positive ion mean? You have 3 electrons less, okay? So in this case, that is the reason why you have 3 electrons less. Be careful. Number 3, how do you calculate the relative abundance? Okay, I talk about how you calculate that, so you can look at it here. As you can see, you do actually need to use X and Y. So I hope your algebra is okay. Question number 3. Question 4. My apologies. 3A is this one. That's easy to do. Question number 4. Yeah, you have to use X and Y simply because, where's the practice test? Question number 4, because you have 2 unknown. However, keep in mind, as you can see here, technically you have X and Y. However, you can actually come up with a way after you simplify. Oh yeah. So essentially, X is this one, Y is this one, but they all add up to 100. So in this case, X would actually be just like the answer key here. X would actually be whatever's left of that minus Y. So you can actually still substitute that in. So you still have a 1 equation, 1 unknown. That's how you solve that question. Again, it is math and algebra. Practice on that. Okay, do some practice question. Let's see. That's a graphing question. That's not it. Yeah. And then question number 9. Question number 9. So this is a part where it is about the steps and explanation rather than calculation. So as you can see here, you're talking about the mass and deflection, talking about frequency, numbers, hit, that will be abundance. So this is a part about really how mass spec work. So I hope this video helps. And if you have any questions, make sure you ask me. I should be walking around and try to do some more. I'll see if I can find more practice questions for you to do. And good luck. Move on to another station to make sure that you're understanding the material. Okay? This is not a difficult task. Okay? Good luck.